Thank you, Divya. Our next speaker is Vincent Hardy, principal scientist at Adobe and longtime W3C participant, who will be talking about graphics design today. Vincent, thanks. Come on up.
All right, hi everybody. So it's a real pleasure to be here. I have two real passions. One is the web, of course, I think everybody here. The other one is graphics. It's not my formal education. For some reason, I went into distributed computing, network management things, but I soon went towards my natural inclination that was graphics. I spent a lot of time at Sun Microsystems where I worked on imperative mode, 2D graphics. That was the Java 2D APIs. And then I started to work on web standard. That was over 10 years ago. I started to work on scalable vector graphics. And that was when this passion came to bloom and be what I was doing on a daily basis. After Sun, I actually left for Oracle, where I worked on data visualization for a while. So I went from building implementations for SVG engines, doing really what a browser is, to be on the user side. So trying to use the technology, trying to do data visualizations on the web was what existed at the time. That was about five years ago. So it was a mix of Flash, SVG, Canvas, whatever was available, we would latch on really. So I've had the two views, and it's been an interesting journey. And since this is my passion, I'm truly happy to come and talk about this today. So today on the web, there's really a lot of things available. So here, those are just thumbnails of demos that I found on the web that I thought were interesting. I'm not going to have a chance to go through all of them. Before I go deeper into the presentation, I should mention that I will make the slides available, and there are links for all those demos, so you'll be able to browse through them. And throughout the presentation, you'll see links to learn more about any given topic for things that I will not be able to cover during the presentation. But let me go and look at a few. So here, for example, we have one that's this is kind of a graphical clock. It's done with a framework called Raphael, and this is done just on the web, and that works on all browsers today. So it's pretty nice to have that type of thing, and that's done with 2D graphics. And I think a beautiful example that I found here is using WebGL, and this is doing shaders and all kinds of powerful 3D effects you have available today that are coming to the web as well, and you can do beautiful artistic effects with great performance today. So that kind of shows you the kind of a little bit of the spectrum of the things you can do, but it's not limited to clocks and cool artistic effects. You can do data visualization, you can do charting. You can do 2D, 3D. You've got a lot of choices in the way you're going to program things. So that's what you can do. Now, how do you do this? So you've got, at your disposal, you've got things for doing 3D. You've got 3D transform. There is WebGL. CSS shaders, which is a new spec coming from W3C that allows you to leverage some of the 3D technology. You've got 2D graphics, of course, with SVG and Canvas. You've got a lot of things for animations. We've got specs for CSS transitions, for CSS animations. SVG has its own declarative markup for animations. You can do scripted animation. You can pick the model, the programming model you want. You can do imperative model. I'll talk about this more later. Or you can do declarative models for your graphics. Then you've got a lot of layout, which is the area of CSS generally. You can do very nice visual effects today with things in Canvas, with things in SVG, and again with the new specs coming with CSS shaders. And of course, the wide spectrum of scripting frameworks we have. So that's a lot to cover, but this is kind of the palette you can choose from when you want to do rich graphics on the web today. So So within 45 minutes, I'm not going to cover all of this. I will focus on what I think is the most immediate thing you can use today. And that's really 2D graphics. So there's a lot of things you can do with 3D, and WebGL is maturing. But the thing that's in really all browsers today is Canvas and SVG. So I will talk about this, and that will be the focus of my presentation. So there are two models for 2D graphics. There's what we call an imperative model. That's the way Canvas works. And there's a declarative model, which is the way SVG works. Note that this model, even though here I'm talking about it in the context of 2D graphics, is you find the same things in 3D graphics. You can have an imperative model for 3D graphics, and that's WebGL. And you can have a declarative model for 3D graphics, and the Web 3D consortium, for example, does a lot of work in that space. Now, the difference is in an imperative model, you're given basically a rectangular area, and those are pixels, and you draw pixels. So you're given facilities to draw pixels in that canvas, but that's really what lives into your HTML page. It's a big array of pixels. By contrast, in SVG or in a declarative model, what you have is something that looks very much like the rest of HTML. So you have nodes, and you've got SVG nodes, graphical elements that you insert into the DOM tree, and they behave very much like the rest of your content. So there are reasons for using one or the other, and my presentation will go over how they can be combined and how they work together. So first, I'll go over the simple examples for both SVG and Canvas. So how many people have used SVG in their work here? All right, so 2 people. How many people use Canvas? Okay, so a few hands as well. So since not everybody's familiar, I think I'll go through the slides. So this is very simple graphics. There are actually, how many circles do you see? 4, right. So actually there are only 2. So the reason is they're drawn. And look at the way it's drawn in SVG. So you've got an SVG element, and you find the width and height of the element as you would expect. That gives you the size of the area in which you're going to draw. And you've got 2 circles. And the reason there are only 2 circles, even though we see 4, is because for each circle, we fill the circle with a color, and we draw the outline of the circle with another color. And that gives a visual impression of 2 circles. But what the important thing to remember here is that you see 2 things. One is graphical elements, in this case a circle. And on the other hand, you've got attributes that control how those graphical elements get rendered. So the circles in this case are stroked with a given color, and they're filled with another color. And so those attributes control the visual rendering and how things get drawn on screen. And that's declarative. You're not writing a program. Now, if we do something very similar in Canvas, let's look at how it differs. So in Canvas, the thing you see in the DOM is a Canvas element. Like I was describing in the earlier slide, this big array of pixels, that's the element you stick into the DOM. And then you write scripts. You write scripts to actually say how you want to touch those pixels and which color they should be. So here we have a function that gets called at initialization time, and what it does is that it grabs a reference to the Canvas element through the get regular DOM interface. So get element by ID, I get a reference to my canvas, and then everything happens through context. So I grab the 2D context to draw into that canvas. This is done so that you could grab a 3D context, or you could imagine different types of contexts. So here we have a special specification that talks about the 2D context for Canvas. And from there on, you make calls to the canvas context. So here we set the fill color and the stroke color. We specified the line width. So those are attributes that control, again, how things get rendered. We haven't rendered anything yet. And then you've got a few calls that will basically define the geometry. So we've got a begin path. Then we draw an arc. The arc is actually the full circle, which we close. And then we have rendering commands, which are fill and stroke. So the 3 things here are attributes which control the way things get rendered. Then we have a call to define the geometry, and then we have calls that are actually rendering calls, things that say now draw this and draw that, which is actually why this is called an immediate mode rendering API or an imperative mode API, because you give it directions, do this now, do that now, and once you've done the rendering, there's no more objects. Only pixels have been touched. So that gives you a very quick overview of kind of the flavor of those APIs. Now, what's involved in graphics rendering? So I was describing the separation between what we render and how it gets rendered. So what we can render in graphics really is three things: basic and complex shapes, so lines, rectangles, circles, ellipses, and also complex shapes like Bezier curves, quadratic curves, cubic curves. So all those are the type of objects you can render. And then text and images. So images being raster images or even vector images in some cases. But those are the basic three graphical objects you deal with in a 2D API context. And the objects themselves, the object that you render in SVG is an element. So it's going to be represented by an image element in your DOM, or it's going to be represented by a rectangle element. Whereas in Canvas, it's represented by a call. So you're going to make a call to fill rect, to fill rectangle, or you're going to make a call to begin path and arc commands, like we saw in the previous example, to actually define the geometry of the object you want to render. So this is the way those two things differ. Now, how this is rendered is defined by that thing called the rendering context. And the rendering context is embodied in Canvas. It's very easy to understand. There's a context object. There's also one in SVG, and it's implicit in SVG. It's like the computed values, if you like, in CSS. Basically, all those properties and attributes that you define in SVG all resolve into setting the proper rendering context for the objects that you've defined. So if I have a rectangle, and after the CSS cascade and defining all my properties, the fill property computes to red. That's the color that will go in the rendering context when I come around and actually draw this rectangle. So in the rendering context, the thing that affect the rendering of objects, you find a lot of things, such as the transform. So the transform lets you take a rectangle and then render it multiple times, rotated, for example, or scaled up or skewed. So that's what transforms are for. You have things like the fill style, so you can render things with a solid color, but you also have gradients and pattern fills. A lot of options for fancier rendering. Same thing for stroke style. You can draw the outline. You can define dashes. You can define the line caps. If you want things at the end to be round or square or butt style. You've got a lot of text and font properties for you come around and draw text. And then you can have, once you have defined all those kind of basic rendering context properties, you can also define things like opacity for different operations, the overall compositing of the objects with a background, or the opacity of a specific operation. So you can, for example, have a different opacity for the fill and the stroke. There are filter effects, and I'll show some example, which is, I think, a really cool feature. You can process basically after you've rendered something. It's now defined by a set of pixels. You can process those pixels and do interesting things with them, like blurring them or creating a drop shadow. And likewise, you can do things with masking and clipping. To do, for example, soft edge mask or something like this. And in SVG, you have markers. So that's a kind of very generic definition of what a rendering context is. And of course, it's not exactly the same in Canvas and SVG. There are fairly wide differences between the two. But from a high level, it's very similar. Now, I'm going to talk a little bit about interactivity, animations, and styling as they relate to 2D graphics. The reason I'm talking about this is because even though this is not exactly rendering, this usually comes along with 2D graphics. So eventing in Canvas, since what you have is this big array of pixels, when it comes to events, you will get an event for your canvas, but you're pretty much on your own from there. So of course, there are frameworks and a lot of things you can do to make it easier. But at the end of the day, you need to understand what a click at a given position in your canvas means, and that's you as a canvas owner it is you who is responsible for figuring out what that event means. In contrast, in SVG, since you've got objects, it works very much like in HTML. I mean, if you've got a click, the HTML, the browser rendering engine will figure out which of the 2D objects was actually hit and dispatch an event to that node. So it's fairly straightforward. And SVG has this nice feature that is called pointer events, which lets you be very precise about what type of event you want on something. So what I'm showing here on the screen is a circle that has a wide stroke. So the circle is in different shades of colors. So for example, the one at the top left has a light blue fill and a darker blue stroke. And if an event is detected on the object, you'll see the label flip. So for example, here, when the pointer event property on the object is set to visible painted, that means that if the object is painted and if it's visible, no matter what the fill and stroke are, the event will be detected. So if I click on it, the event was detected, and I hook that up into a small animation so that the animation is triggered by the event. So if the event is not received, the animation doesn't trigger, you don't see anything. So here, the second one is on visible fill. So the event will be detected if I hit the fill area and the element is visible. So if I click in the middle here in the fill, I get detected. If I click on the outer edge, I don't see the title flip, and that's because I hit the stroke. Therefore, the object is not sensitive to the input. So you get the idea. You've got very fine control over eventing and objects in your 2D graphic. And that's the way the code works here. You have the pointer event property set on the circle that we were just seeing, and there's an animation. In this case, an animate transform on the label that is bound to the click event on the circle, and this click event will happen or not depending on the pointer event setting. For scripting, so in Canvas and SVG, you've got scripting APIs. I mean, Canvas is a scripting API, so there is that API to look at. And for SVG, in addition to being declarative, you've got the DOM API that gives you access to a lot of text features, for example, for measuring text, and you can do fairly advanced typographic features with the SVG text APIs. You can also manipulate path data pretty easily, as the next demo shows. So let me show this demo. So this one's called Pebble, and the Pebbles demo, what it does is that it's actually not true text you'll see. Let me run it, and then I'll explain what it does. So here you see a lot of those little things that appear, and they're placed around a path. And they kind of move around randomly with a kind of cute animation effect. And this is done by taking the outline of the SVG text, and through the SVG APIs, we're able to get different points along that path, and then position those little bubbles around the path and animate them. So that's very fine control and very useful access you get from the DOM, and then you can do effects like this and morph it to something else. So that's kind of things you can do with the scripting APIs we have. Now for animations, so animation, there are really multiple ways of animation, and this is to a large extent still in the works in the standards. So there, of course, there is scripted API, and that's what a lot of people resort to today, because there's not always either wide support or consistent enough support for animation. But as, so in Canvas, that's what you do. I mean, you do animation with your scripts. In SVG, you could do several things. You can do scripted animation. You could do CSS animation with browsers, which start supporting CSS animation on the SVG CSS properties, such as fill and stroke. So the support starts to be pretty good. And you can do declarative animation with Smile, which is something that all the browsers except IE support at this time. So this is an example of animating a path. So if I click on this, it just morphed this cross to a path. And that's actually fairly simple to express. The way this works is you've got a path element, which has the D attribute on the path element defines the geometry of the path. And the animate element that we've already seen before just declares that it's animating the path attribute. It's saying it declares which path is going to. So that's the check mark at the end of the animation. It declares when it begins. So it begins when you actually click on a specific element. It gives a duration, and it says that it freezes at the end of the animation. That means it stays in the same state as the last frame of the animation. So that's pretty powerful, and it's convenient, can be generated, and it can also be manipulated with the DOM. One thing I wanted to touch on briefly is the timing and synchronization, because there's a lot of enthusiasm for CSS animation and CSS transitions. I'm personally a big fan as well, and I really hope we'll see them widely interoperable with SVG. But one thing that you don't get with CSS animation and transitions is really synchronization and eventing between animations. So if I have one animation and I want that to trigger another animation, there is no way for me to declare that. I have to hook in scripts, listen to events, and depending on the animation, on the implementation, I may actually have slight delay that can ruin my whole animation. So I want to show the advantage of having a declarative animation. So here I have this little demo. Here, when so you've seen those games, right? And so here, this is done very simply by hooking up two animations. So imagine that I have a bunch of spheres, and the one on the left-hand side is a gray sphere, and it has an animation called the gray sphere anim. In the golden sphere animation, which is here, I can simply say that I want to begin when the other animation ends. And that's very simple, very straightforward. So I can just say, when you're done swinging, start the other one, and then the other one swings. So that's what synchronization is about, and that's a big need. It's in Smile, and in whatever upcoming solution we come up in the W3C for animation, I hope we'll build in nice synchronization features like this. Last thing I wanted to show is a styling example. So in SVG, since SVG uses the CSS tile system, you can actually style your SVG documents like you would any other document. So this is a simple graphics which has this background cloud and a little piece of text on the background. And it just has alternate style sheets like you can do in HTML. And I have a little switch at the top that lets me switch between style sheets. So I can go between neutral and colored, and or black and white if I wanted to print it. But the nice thing here is I can design my content to be more accessible. For example, to have a high contrast version. That's that's important. Or for print, for example, to use less ink. Well, sorry. So that's one of the nice features of having integrated web formats. All right, one thing that's interesting to look at too is the way graphics integrate with the other thing that make for rich user experience. That's multimedia. So how do graphics integrate with audio and video, for example? So for audio, we have the audio tag. Obviously, and that can be used with Canvas. Canvas being part of HTML5, so that you can use those things. There are events in the HTML media events. You get all the data you need to know when your audio or video file is loaded. You can get progress events to know exactly at what time the audio is. So if you want to track it. So that can be used with both Canvas and SVG. And in SVG, you can use it. If you use SVG inline a document, you can have a parallel audio element in your HTML content. If you use SVG standalone, you can still embed your audio as a foreign object in your SVG file. Something that's kind of interesting is the Web Audio API. So the Web Audio API is in the works in W3C. As I understand it, there are multiple proposals. But the effort is very interesting. It's going to give us data about the frequencies of the audio at any given time when the audio is playing, and you can do interesting things when you hook that up with graphics. So I have two demos that illustrate how you could integrate 2D graphics and audio. So let me show you the first one here. So this one is fairly simple. What it does, it's kind of a karaoke demo. I took a song, I wrote down the lyrics, and then I timed it. So I looked at when each lyric was going to play. And then I coupled that with 2D graphics so that I'll fly in the lyrics as the audio plays, and you'll see there is a bunch of animation effect going on. So.
In the silence there are many sounds. In the dark the colors dance around. So many nights I pray all the wishes that I made.
Okay, so that's the first one, and this is using a simple audio tag and just using scripting timing features to just play the track at the right time. The next demo I have here is using the Web Audio API, and that's a little different. So here I have this bunch of characters. They're randomly generated, and they're trying to give you a kind of a happy mood. So most of the characters are smiling. Some seem startled to see so many people here in the audience. I thought it would be funny to have a reflection to the audience. And each one is hooked to a specific frequency in the audio files. I use the same audio, but I use it with a different API. So look at how the different characters actually jump up and down as the audio plays. All right.
In the silence there are many sounds.
So I didn't quite finish the demo. I wanted them to smile more when they are higher, but all right. So obviously in multimedia, the other thing you want to look at is video, and so Canvas has this really cool feature of being able to render a video into a canvas, and that enables all kinds of use cases. This one is using this video, and if I click this button, what it does is through the API that are available, it seeks through the video file and takes snapshots at regular intervals. So that now I have this little interface, and when I click on the interface, I can move to different places in the movie because I kind of recognize the parts of the movie I want to see. So that's pretty powerful, and once you've got this canvas, once you've grabbed the video frame, you could do all kinds of things. You could do filtering, etc. With it. So that's a pretty powerful feature. And that's very simple to implement. If you have your canvas context, you get your video element with regular, that's vanilla HTML DOM programming. You should say document.getElement by ID. Sorry about this. And then you just drew a draw image. Instead of passing an image, you pass a video element, and that will render the current frame of your video stream. You can also do video in SVG. Now I'm going to switch to a different browser. All right, so you see why I'm switching to a different browser. Okay, so now this is in Firefox, and what I'm doing here is I have a video element that's embedded into the SVG document, so it's inline SVG. And since SVG has filter effects, on the left-hand side of the video, I apply a filter effect, and on the right-hand side, there's no filter effect applied. And Now this is playing, and you can see that the filter effect's actually applied real time as frames come in. The filter effect applies, and this is interleaved with SVG elements. So there is the background is SVG, behind the video it's SVG, and the foreground, those little decorations, are actually SVG path data. And the filter effect here is doing a grayscale effect and kind of a soft blur type of effect. It's a pretty heavy duty effect, but as you see, it's performing quite well here in Firefox. All right. So now one thing that this has been asked many times, like why do we have two different models for 2D graphics, and do we need that, and what's the deal? So yeah, there are differences. They have differences, and largely, Canvas is a pretty low-level API. It's very useful. You've got pixel access to it, but you're missing things like DOM events, styling, the real HTML integration, and you're on your own for a lot of things like animation. By contrast, SVG is very declarative, has a nice API, has DOM integration and eventing, but it doesn't give you pixel access. So everything you draw has to be a DOM element, and sometimes that's limiting if you want to draw a lot of them. And I'll show examples of that. So yes, they are different, and you could argue for a long time that there are pros and cons, but I think it's a false debate. Frankly, if you start debating if you need SVG, if you have Canvas, you could as well debate if you need HTML because you have Canvas, because after all, Canvas can draw lines, boxes, and text, and you could pretty much do everything that HTML does visually. So I don't think that's the real debate. So there is no, the answer to this question is, I think, no. There are use cases for both, and that's an example of how you might need to actually combine the two. So this is a demo that I wrote a while back, and what this does is it's using a markup language called GML. It's a graffiti markup language. Yes, that exists. And there's a whole community of people who capture GML files, and they have fancy things to actually record the artist drawing graffitis. And I had seen a beautiful example that was done in 3D, and I thought I'd do kind of a small version of that with 2D, and I wanted to have this spray paint effect. And I also wanted to be able to save the stroke itself as an SVG file to edit it in Illustrator or something. And clearly, when you do spray paint, you're going to draw zillions of tiny rectangles on the canvas. So this is really a pure rendering operation. It's really, you just want to touch pixels. You don't want interactivity with it. You don't want to manipulate it. You don't want to hook up an event handler to that a tiny piece of paint that touches the canvas. And that's an example where SVG and Canvas are really usefully combined together. I could use SVG for the stroking of the graffiti and Canvas to do the spray paint effect. So the point here is that those two things are good complement, and there are times where one is useful and times where the other one is useful. And I think that really depends on what you do. So for example, how many objects are you going to draw? If you've got really large number of objects and you don't need interactivity with them, Canvas is a really good way to deal with that, because once you've drawn something, it's basically a pixel in an image, and that's it. There's no more cost to it. There's no overhead. There's no DOM overhead to it. But if you need, integration with tools for manipulating the drawing, or if you need to manipulate the animation, etc., well, maybe a declarative form will be more useful. And sometimes, the two can be combined, as I just showed. Now, talking about how you combine things, I think that's where it gets real interesting. So what are the ways we can combine HTML, Canvas, and SVG? They're all part of the Happy HTML5 family. So these are a few examples. So first off, you can put HTML in SVG. There is something called the foreign object in SVG. It lets you, it's kind of an escape hatch for SVG, and within your foreign object, you can stick in HTML. So that's what's done here. The background cloud, this is an image in the center. The SVG image contains this cloud with a drop shadow effect, so it has a filter effect applied to it. And inside the cloud, I've stuck a foreign object. like so, which is part of my group, my cloud group. And the foreign object just contains a body element and then my HTML. So that's pretty straightforward. So if I want to have text and a text box and multi-line text in my content, I can, and I can do that fairly easily. Another way you can integrate SVG in Canvas is, remember that picture, SVG is basically a tree of DOM nodes. One thing I can do is, with a foreign object, I can stick in a canvas element within my SVG DOM tree. And now I have a layer in my DOM tree, which is a canvas layer. That's what this example kind of symbolizes here. In the back, you see one of the spheres is behind the grid. So that's kind of my first layer in my SVG content. The grid kind of visualizes the SVG canvas that I inserted into my SVG DOM. And then the sphere on the right is another SVG element that's now on front of my canvas. So I have a sphere in the back, the canvas in front of it, and then in front of my canvas I have another sphere which is also SVG. And I can actually draw in this live. So I can clear and draw in my canvas here. The canvas layer text is actually drawn into the canvas. And if I clear, I just clear the canvas. So those two things can work and be live together, which can be very useful. Now, another example here is of when you might want to use this. SVG has patterns which are useful, so you can draw anything in a pattern and have this be the paint object for your SVG content. So here I wanted to do an effect with a pattern that's actually semi-random. So those curves are actually random, and let me show you how they are. So if I reload this page multiple times, you'll see that it changes every time I load it. And if you pay close attention, you'll see there are actually two different patterns, one for the front and one for the back. If you look at the lines, they actually change colors, and that's because they're actually different patterns. And there is a filter effect applied to the text object, which is still text. So you could do this in SVG, but the problem is that if you do that in SVG, you'll have a ton of lines that are sitting there in the DOM just for the purpose of the pattern, and I have no intention to have interactivity with that pattern or every single line of the pattern. So instead of holding all that baggage into my DOM, what the demo does instead is that if it renders a pattern into an off-screen canvas and then uses that the content of the canvas to stick in as an image that SVG uses as a pattern. So that's a much lighter way of creating the SVG content, and you can still do that at the proper resolution because you can create a pattern once you know your device resolution. So this is using this very convenient method on Canvas that's called toData_URL. And basically toData_URL takes all the pixels from the canvas, encode them as an image, and do base64 encoding, which is pretty inefficient. But there are plans to do better with something called toBlob, which will be a better way to deal with the exchange of bulky data and avoid this base64 encoding issue, which can be very large. Unfortunately, it's not really well implemented at the moment, but my hope is that it will soon. It will be soon. Then finally, since we're talking about bridges and how you can use one thing in Canvas in SVG or vice versa, this last example is using SVG in Canvas. And one of the cool things with Canvas is that you can draw video, you can draw images, and part of the images one type of images you can draw in a Canvas is an SVG image. So here, let me show you one. So here, the black rectangle is a canvas, and each of the icons that is drawn is an SVG image. But the effect I wanted to create here requires me drawing the same SVG image a lot of time to create the visual effect I wanted to get. Now, I could, again, do that in SVG, but that will create a pretty bulky DOM, and I may run out of memory. And again, I don't need interactivity with all those bicycles and cars I've put on screen. I just want the visual effect. So pretty straightforward here. I create the canvas. I load my images like I would create any other PNG image or JPEG image. And then I draw them once in an off-screen canvas. And then I draw those off-screen canvas repeatedly into the main canvas. So I think the takeaway here that you can do things efficiently by combining SVG and canvas. All right. So one of the nice things today is that there's lots of frameworks you can use for all kinds of things. jQuery, YUI, all kinds of things. There are frameworks specialized for 2D graphics, and so why would you use this versus not do things on your own? Well, so first off, there are some frameworks that are polyfills. I mean, they will implement a feature ahead of the browser and kind of let you pretend you're using a modern browser. Sometimes frameworks provide domain-specific features, for example, for graphics, data visualization. And it's sometimes convenient to have something that understands a little bit about your domain and not just the raw, basic graphics features. Sometimes you want something for portability because as much as we like Canvas and SVG, sometimes you're in environments where those are not available or they're not fully available. So you may want to have a framework that kind of isolates you from those dependencies. And sometimes you may want to use a framework because some of the the APIs the standard has to offer are not the prettiest one. The SVG DOM is is what it is, and it's sometimes a little bit cumbersome to use. So the type of frameworks, given the time, I won't go into details, but there are references in the slides. So Rafaela.js is a pretty popular one. It lets you do graphics in, it isolates you from the rendering platform. It works very well with SVG. There was an implementation for VML as well. Paper.js is a scripting framework that's on top of Canvas. It comes from Scriptographer. Scriptographer was a scripting plugin for Adobe Illustrator, and people have kind of applied the same concept for this framework that works on top of Canvas. Easel.js comes from Grant Skinner. And he was a long-time Flash developer, and recently he's focused his interest in HTML5 graphics. He's done amazing work with it. I encourage you to check out this game called Pirates Love Daisies, and it's all done with HTML5 graphics, and it's really cool. And he's made the framework that he uses for developing that he made to develop that game. He made that framework available. And then finally, there's D3.js. There is a talk during this conference I really encourage everybody to follow from Michael Bostock. It's a really beautiful framework. Then finally, you have utilities such as CanVG, which I think is interesting. There are some limitations on some platforms. So for example, some browsers have Canvas support, but they don't have SVG support. So that could be one reason where you would like a library that can actually take SVG and render it into a canvas. Another reason that people can use CanVG for is if you actually need to get the rendering of your SVG as a bitmap image, you need to use CanVG today because the browser security model currently considers any rendering of SVG as tainting the canvas. So once you've rendered an SVG image into a canvas, you can no longer get the pixels out of the canvas unless you use CanVG. So that type of problem that you run into if you actually do active development with those APIs, typically you find libraries that will solve the problem. So of course, this list is not exhaustive. It's not everything that's available. I didn't present them in any order. It's not a recommendation for any particular use. I encourage people to look at what's available, try them out, and see what's appropriate for your need. Be careful, as usual, with frameworks. Make sure you use something that has a lively community and support, not something that will be discontinued shortly. So. The status of today, it's pretty good. I mean, Canvas has really a good support. It's in all browsers and it performs well. So it's certainly something you can use. SVG support is also very good. It's gone a long way, in 10 years, and with IE adopting it a couple of years ago, this made a really big difference for SVG, and the support is really very nice. There are two kind of nits with, they're not nits, but there are two issues with SVG support. One is the lack of support for SVG fonts in two browsers, and the lack of Smile support, declarative animation in one browser. And that's a little unfortunate because when you're looking at creating content, you've got almost everything working, but there's one or two things that are not available. So it would be nice if we got there and went the final few steps to get the good coverage for every developer. WebGL is coming. I mean, it's implemented in most of the browsers. Again, IE here hasn't announced any support for WebGL, so I'm not sure what the plan there will be. But other than IE, you start having pretty good support for WebGL. There are also some it's not. I don't want to draw too much of a rosy picture for Canvas and SVG. You do get into problems with especially inline SVG, but those are things that the group the SVG working group is working on. So next, there's a lot of things coming. Improved integration into HTML. Canvas and SVG. For example, we should be able to put a canvas directly into an SVG without wrapping it into a foreign object element, for example. Better 2D and 3D integration. Trying to get 3D transforms to work the same way in SVG as they do in CSS, and to actually have the same model for both. So that's something that I'm actually just starting to work on personally in the W3C. The SVG working group is gathering new requirements for SVG 2.0. So the developer, if you've got things you want to see in this spec, please provide feedback to the working group. And there's work happening in implementations. So here are a few more things. There's typography. I didn't get a chance to talk too much about text, but there are really cool things you can do about text. And Christopher Sly has a presentation during this conference. He'll talk more about typography. And so the presentation is made in HTML5. So what you saw is in HTML5. It's done with a tool by Hakim El Hattab with some modifications, some tweaks I did. But I really enjoyed working with the tool he created to create this presentation. There are references here to the other content I used. And then when the slides are available, there's a whole section about references where you can get the frameworks, etc. And that's all. So thank you very much for listening. And if you have questions, I think I'll take them during the lunch break. Thanks. I should have said one more thing.